What actually happens in your brain when you have depression? Not just emotionally, mentally, but biologically. Because depression is not simply feeling sad. According to current research, it is associated with measurable changes in the brain itself, changes that can affect memory, motivation, emotional balance, and even the way the brain responds to stress. One of the most consistent findings in major depressive disorder is that certain brain regions can change over time, especially the hippocampus and the medial prefrontal cortex. Research has linked reductions in the volume of these regions to markers of illness progression, including a greater number of depressive episodes, longer illness duration, and treatment resistance. These are not just theories. They are changes that can be detected with brain imaging, including MRI. The hippocampus is especially important because it helps with memory formation and emotional context. It is also one of the brain regions most vulnerable to stress. That helps explain why depression often comes with difficulty concentrating, memory problems, and a sense that emotions become harder to place in perspective. Another major region involved is the prefrontal cortex, especially the areas that help with planning, decision-making, and emotional regulation. In depression, this region is one of the most consistently impaired. At the same time, the amygdala, which helps process threat and emotional significance, often shows increased activity. In simple terms, this can create a painful imbalance. The brain becomes more sensitive to negative information, while the systems that normally help regulate those feelings become less effective. That may be one reason depression can feel like being trapped inside negative emotions while also struggling to think clearly, make decisions, or feel relief from things that would normally matter. Research also shows that chronic stress can dysregulate the HPA axis, the body's central stress response system involving the hypothalamus, pituitary gland, and adrenal glands. When that system becomes overactivated, cortisol levels can remain elevated for too long. According to current evidence, excess cortisol can contribute to damage in the hippocampus and prefrontal cortex, both of which are deeply involved in mood regulation. In other words, a brain under prolonged stress may gradually become less able to regulate that stress well. Another important piece is BDNF, or brain-derived neurotrophic factor. This protein plays a crucial role in helping neurons survive, grow, and strengthen their connections. In depression, reduced BDNF has been associated with lower neuroplasticity, the brain's ability to adapt, rewire, and recover. Research also links this reduction to greater symptom severity and resistance to antidepressant treatment in some cases. So depression is not only about mood, it may also involve a brain that becomes less biologically flexible over time. Depression has also been consistently linked to inflammatory signaling. Higher levels of pro-inflammatory cytokines such as IL-1 beta, IL-6, and TNF-alpha have been associated with more severe depressive symptoms. Current evidence suggests that peripheral inflammation can worsen inflammation in the brain through multiple pathways, including disruption of the blood-brain barrier, immune cell trafficking, and activation of glial cells. These processes can interfere with neurotransmitter production, neuroplasticity, and mood regulation. This is one more reason depression should not be treated as just in someone's head in the dismissive sense. It is tied to real biological processes. So what happens in your brain when you have depression? According to current research, depression is associated with measurable changes in the brain's emotional circuits, stress system, plasticity, and inflammatory state. The hippocampus may shrink. The prefrontal cortex may struggle to regulate emotion. The amygdala may become more reactive. Stress hormones may stay elevated. Plasticity may weaken. inflammation may rise. And together, these changes can make depression feel overwhelming, persistent, and deeply physical, not because a person is weak, but because the brain itself is under real strain. If there is one thing the science makes clear, it is this: depression is not a failure of character. It is a condition with measurable effects on the brain.